All right, this first section is going to be a little review of your pre-cal knowledge from your polar graphing. First thing was just two plotting points. Now, your polar graphs are going to be written in the form of r comma theta, where r is the radius and theta is going to be the angle that is created from the positive x-axis, where positive rotation is counterclockwise, negative rotation is counterclockwise. And r is going to be the radius, which is the distance from the origin. And these are called polar coordinates because the origin is the reference point, which is going to be called the pole. And so the pole is going to be, or the radius is going to be the distance from the pole to the point that we're referring to. So in this first problem, we have the point 3 pi over 6. So if you rotate pi over 6 first and then go out 3 units, so 1, 2, 3, that will be the location for this point, and that is point P. All right, so the next one is 120 degrees. So 120 degrees will be rotated around to here. 2 pi over 3 is the same thing as 120 degrees. Now, if the radius is a positive value, then you go along that line for the 120 degrees. However, if it is a negative radius, that means you go in the opposite direction. So this coordinate will be the -2. All right, and that is going to be coordinate for point R. All right, so the next one has a negative angle. So the negative angle is going to be the negative rotation, which is right here, and pi over 3, negative pi over 3 will be this line, and then 1.5 will be located right here. And that is going to be the coordinate for point S. All right, so this next one says to plot each point with the given polar coordinates, then find 3 additional polar representations for each point with the given polar coordinates. All right, so if we just take a look at this first problem, the rotation is negative, so we're going to be rotating clockwise. 2 pi over 3 means we're going to rotate this direction to about right here. And 3 means we'll just come out 3 units from the origin or the pole. All right, so if we draw a line for pi over 3, and the radius of 3 we'll just call this a distance of 3 right there. And that'll be the coordinates for point A. Now, there are different ways that you can write those coordinates. That was using a negative rotation. We could also use a positive rotation, and in that situation, this would be the angle 4 pi over 3. And the radius is still 3. We could also use a negative radius. If we use a negative radius, then that means we use this as the angle. This angle is pi over 3. All right, so we can use pi over 3, where the radius is -3. All right, so that would be rotating this way, and then the negative angle goes the opposite direction. Now, we did a negative rotation to here, and we did the positive rotation to here. We can also use the same kind of rotations on this line. We could call this a rotation of 5 pi over 3 and the radius being negative 3. Now these are not the only ways to write the coordinates for that point. There are actually an infinite number of ways of writing them, and this is just one set of ways that this can be done. All right, so I went ahead and took the liberty of working through the next problem and just displaying it. So the coordinate here is -2, -150. So negative 150 degrees would be rotated this direction. The -2 radius, however, doesn't go along this line. It goes the opposite direction. So this would be your coordinate for -2, -150 degrees. There are different ways of writing that. I just used all degrees for this since it started out in degrees. And so using degrees, I could just call this a rotation of 30 degrees and going out a +2. And then these are other ways that I could label that point as well. Again, these are not the only ways of labeling this. These are just a sampling of ways to label those 2 points. All right, so what we're doing here, it says, is find the rectangular coordinates for each point with the given polar coordinates. Now, rectangular coordinates are written in terms of x and y. So that's what we need to do, is put these in terms of x and y. Now, just a little review. If you have a coordinate right here that is x and y, this would be theta, and this is r. Well, we know from our trig functions, just right triangle trig, that the cosine of the cosine of theta is equal to adjacent over hypotenuse, which means x is equal to r times the cosine of theta. And we also know that the sine of theta is equal to y divided by r, which means y is equal to r times the sine of theta. All right, so we're going to be using those values or formulas for being able to come up with rectangular coordinates. These are the polar coordinates, meaning this is your r value and this is your theta. So that means that x would equal the r times the cosine of theta, -pi/4. Well, the cosine of -pi/4 is √2/2. And multiplying that by 10 gives us 5√2. We know y is equal to r times the sine of theta, so -pi/4. The sine of -pi/4 is -√2/2. Multiplying that by 10 gives us -5√2. Putting those into coordinate form, be x, comma, y. Okay, I just went ahead and filled in the rest of the problems on this page. They just kind of work similarly. For example, on number 7, we have the radius and the angle. So x is equal to the radius cosine of the angle, giving us this value, and y is equal to r sine of the angle, giving us this value. And then numbers 8 and 9, these are calculator questions on here. These come out to decimal values. All right, for the next set of problems, what we're going to be doing is finding the polar coordinates, meaning we need to find out what does r equal and what does theta equal so that we can write them in the format of r comma theta. Now, r is going to be the length of the segment running from the pole or the origin to the point. So if the rectangular coordinates are 5, -5, that would put the point right here. And if you do Pythagorean theorem with this, you're going to get a value here of 5√2. That is going to be the radius. All right, so theta is going to be the angle that we are rotating, and we can use theta right here as the negative rotation, and when these two segments are the same, that puts us at a pi/4 situation, or 45 degrees, and it's a negative rotation, so that gives us a negative pi/4. So the coordinate then would be 5√2 comma negative pi/4. Now the next coordinate was 0, 9. This coordinate is right here, and the radius is just simply 9 because it's on the axis, so 9 is the radius. And the angle here will be rotation to here from here to here is pi/2. So that one was pretty easy to work out there. All right, so the next problem, we have -4 comma 4√3. So if you go for this direction and 4√3 up this direction, one of the things you might recognize is that these are the properties for a 30, 60, 90 triangle. If you remember your geometry rules here, the short leg, if you multiply it by √3, that will give you the long leg, and if you double it, that will give you the hypotenuse. So the hypotenuse here is going to have a length of 8. Now, you can also just simply do Pythagorean theorem with this and come up with 8 as well. All right, so the radius is 8, and the angle here, well, this is a 60-degree angle, which means from here to here is 120, and that puts us at 2 pi/3 for this. And then the last one is really a very similar situation to this one. The radius comes out to 1 on this, and the angle is also at 2 pi/3. All right, so the next set of problems here says to convert each polar equation into rectangular form. So a polar equation is going to be written in terms of r and theta, and we need to convert it into a rectangular form, which is in terms of x and y. All right, so one of the things that we should remember from pre-cal and algebra 2 is that x squared plus y squared equals r squared is the equation of a circle. And so when we're dealing with polar equations, we're dealing with rotations, and circles are a part of that. So that simply means right here that r would equal the square root of x squared plus y squared. And this can be substituted into this problem, giving us square root of x squared plus y squared is equal to square root of 5. And we could square both sides of this equation, which would give us x squared plus y squared is equal to 5. All right, so the next problem, cosecant can be written as the reciprocal identity here, which is 1 over sine of theta. and we can multiply sine theta over to the other side of the equation, which gives us r sine of theta is equal to 2. And if we remember from the other slide, r sine of theta is equivalent to y. So that gives us the equation y is equal to 2. And do a similar type thing with this problem here, where secant is equal to 1 over cosine of theta, multiplying cosine of theta to the other side gives us this, and r cosine of theta is equivalent to x. So x equals -1 would be this equation. All right, number 17 is going to involve a little bit more work. And so what we need to do is we need to work on getting rid of r and theta in this problem. Now, one thing to remember here is that r is equal to square root of x squared plus y squared. All right, so what I'm going to do is we're going to start this problem by dividing by sine. And that's going to give us r over sine of theta is equal to -6. And pardon me. And we know that y is equal to r sine theta, which means sine of theta is equal to y divided by r. All right, so we can do a little conversion here and say that sine of theta is therefore equal to y over the square root of x squared plus y squared. And we know that sine of theta is equal to r divided by -6. All right, let me go back up here to the top. This is a true statement, but it's not the one that we need. What I need here is going to be the sine of theta is equal to r over -6. Because what I can do now is I can replace this with r over -6. And we know what r is in terms of x and y. All right, so we're going to have r over -6 equals y over square root x squared plus y squared. And we can input this square root in place of the r. So that's going to give us square root x squared plus y squared over -6 equals y over square root x squared plus y squared. Now this looks like a fairly complicated problem here, but it can be simplified because if you cross multiply, because this is a proportion, so we can cross multiply this way. You're multiplying something by itself, which means you're squaring it, which is going to get rid of our square root. So you're going to end up with just simply x squared plus y squared equals, and then multiply this way is -6y. And we can bring the 6y over here by adding it. And we can actually do a little magic here by completing the square. That would mean adding 9 to both sides of our equation. And that would make this x squared plus y plus 3 squared equals 9. That is the equation for a circle centered at 0, -3, with a radius of 3. So that's what this equation would generate. All right, so now we're going to work on converting these rectangular forms to polar forms. Now, real quick, just to remember that x squared plus y squared is equal to r squared, which is equal to 7. Therefore, r is equal to the square root of 7. All right, so the next problem here, we're going to replace x with r cosine theta, and we're going to replace y with r sine of theta. Because we're trying to convert this to polar form, which means we need to get rid of x's and y's and input r's and thetas. All right, so we can actually factor an r out of both of these, which leaves us with r times 3 cosine theta minus 2 sine theta equals 1. Therefore, r is equal to 1 divided by that parenthesis. All right, so the next problem here, we can look at this because we know x squared plus y squared is r squared. So I can think of this as 2 times x squared plus y squared plus 5 times x, and we know x is equal to r cosine theta. And so I'll put the r squared in here. And we can factor an r out of each of these. So that would give us r times 2r plus 5 cosine theta equals 1. Oops. I need to do something real quick. And if you didn't notice this, I just now noticed these are not equal to 1, they are equal to 0. I was looking at the 1 from up here. So let me replace these with zeros here. All right, so what that means is that either this is equal to 0 or this is equal to 0. That gives us two equations. Now, the first equation is useless, because if you have a circle with a radius of 0, that means there really is no circle. There's no graph here for this. So r equals 0 just kind of goes away. It doesn't mean anything. All right, so then we have this other graph right here, and we could solve for r just like we would solve for y. And so in this situation, you would have r is equal to -5/2 cosine of theta. All right, and then the last problem here, what I would do is I would multiply this out. Let me just do this over here on the side, and that would give us x squared plus y squared minus 4y plus 4 And then we've got a minus 4 right here, so tack that on, and equals 0. All right, so what we can do with this is, like before, we know this is equal to r squared. We know y is equal to r sine theta. And then we know 4 minus 4 is 0, so that goes away. And we can factor an r out, leaves us with r minus 4 sine theta equals 0. So once again we get r equals 0, which is nothing, or r minus 4 sine theta would equal 0, which means r is equal to 4 sine theta. And that would be our answer right there.